Along this AI popularity, you may have surely seen several applications that generate synthetic faces or recognize facial expressions among other functionalities. This is a shift by training machine learning models with huge amounts of, in this case, face image data. One relevant dataset is the Flickr-Faces-HQ or FFHQ dataset. This is the most widely used face dataset for a wide variety of applications, ranging from face recognition to region gender recognition. It is composed by 70,000 high-quality PNG images with considerable variations in terms of age, ethnicity, and image background. It also includes other external elements in their images, like hats or glasses, to make it as general as possible. These images were crawled from Flickr, an online image hosting platform very popular for travelers, photographers, and content creators, which is very useful for managing and sharing multimedia content. Other key feature of this website is the supporting of Creative Commons licensing. This allows users to specify the permissions for the use of their images by others. But let's leave it like that for a moment. We are going to explore this deeper in a few minutes. As mentioned before, this image data was extracted from internet with a technique called web scraping. It involves fetching and parsing the HTML code of a web page to extract relevant information such as text, images, links, and more. This data can then be structured and stored for various purposes like content aggregation, business intelligence, price monitoring, and data collection and analysis. This last one gathers data for analysis or research, and this is for what FFHQ was created. Now, web scraping is not infallible. This means that there may be duplicated, corrupted, or incorrect data within the dataset, and they will impact the results if not removed. To solve this, we need to perform a data cleaning. This pre-processing step is crucial in the data science pipeline and involves detecting and removing erroneous data in our dataset. This may be a complex process that can be done either manually or using specialized algorithms depending on the problem. For FFHQ case, some automatic filters were used to initially prune this dataset, and finally, the remaining inaccuracies like stereos images, paintings, or photos were removed by crowd workers hired through the Amazon Mechanical Turk. Afterwards, all web-scraped images were automatically aligned and cropped using dlib. Every material in Flickr can be uploaded with a certain license given by Creative Commons. Creative Commons licenses make copyright easier to understand, making permission explicit and straightforward. They use icons to indicate the different terms of the license. These are, first of all, non-commercial use. This means that you cannot profit from the material. Then we have no derivative, which restricts sharing changes of the original material. Share alike allows other users make changes, but they have to be shared under the same license as the original work. And finally, we have the attribution term, meaning that the credit must be given to the creator. All icons can be mixed to create the 6 different existing license types, going from the less to the most restrictive. According to the GitHub repository of FFHQ, only images under permissive licenses were collected. Thus, nearly 92% of the dataset, this is around 60,000 images, includes photos with Creative Commons by and Creative Commons by non-commercial images. The rest of them are either public domain, US government, or Creative Commons 0, which means that there is no copyright, so you can use them freely. FFHQ dataset was originally created as a benchmark for generative adversarial networks, a machine learning model consisting of two simultaneously trained neural networks. A generator that creates new synthetic data samples and the discriminator whose task is to classify between real data, it means from the actual dataset, and the fake data produced by the generator. This feature is a cornerstone for human face generation, like StyleGAN, a generative adversarial network published in 2019 by NVIDIA researchers, in where two images from the dataset were combined to create a synthetic result. Other interesting applications are deepfake detectors, specialized for individual face parts. Nowadays, deepfake technology is too well developed that AI-generated faces are sometimes indistinguishable from other real ones, making you very susceptible to fall easily into fakes, like this one very famous of actor Tom Cruise. This approach is based on a dynamic configuration of an ensemble model that consists of deepfake detectors. They are based on convolutional neural networks and are specialized to detect deepfakes by focusing on individual parts of the face. It has been also developed some controversial applications regarding biometrics. Since the entry into force of the General Data Protection Regulation, biometric data has acquired legal recognition of a special category of personal data. This means they are now subject to a strict data protection regime. We are not going to dive very deep into this topic, but researchers proposed a solution to this problem, developing privacy-friendly biometrics from synthetic faces. These are generated, for example, using the already mentioned StyleGAN. Finally, we have other interesting applications like photorealistic facial wrinkles removal and 3D face reconstruction. Let's now take a deeper look into the metadata of this dataset. Each image is categorized whether it's for training or validation. At the same time, it includes the Flickr URL, author, country where the photo was taken, its respective license, and the dates of uploading and crawling from Flickr. However, some of this information might represent an issue. In 2021, the European Commission proposed the Artificial Intelligence Act with the aim of establishing a first regulatory framework on AI. They suggest different rules for different risk levels. In our context, the most relevant are the high risk and unacceptable risk in AI research. The high risk label is used to describe applications that negatively affect the safety or fundamental rights. And the unacceptable risk label includes real-time and remote biometric identification systems such as facial recognition. Therefore, most of the data within the dataset could fall in this last category. According to the website Exposing AI, a potential major issue with the FFHQ dataset is that it includes biometric data in the form of 68-point facial landmarks, as well as the real names without informed consent of the individuals in the photo. That's why NVIDIA offered the possibility of removing photos from the dataset. However, it is not obvious to spot whether or not an image is already in this image collection. So, we already had a first insight on Flickr-Faces-HQ dataset. It includes a huge amount of web-scraped images of human faces from different geographical and ethnical origins with various types of licenses. With this dataset, some applications like synthetic face generation, deepfake detection, and some biometrics can be performed. As nearly the half of the dataset is composed by images with non-commercial license, as well as there is some metadata that may compromise people's privacy, this dataset should not be used for the development or improvement of facial recognition technologies. However, if you want to create basic non-commercial machine learning applications to learn, this is definitely a very good dataset to work with.